Good day, students. Today we're going to look at section 9.2, which is on plane curves and parametric equations. I'm going to go ahead and share my screen with you guys so that you can see my presentation. All right, we're going to do, I have 4 examples, but we're really going to do only 3 together. The first one is to sketch a curve based on a parametric equation. And all a parametric equation is instead of having an equation where it's just one thing, you have an equation that's written in terms of 2 things. So for example, here we have part of the equation tells us what the x-coordinate is, and the other equation tells us what the y-coordinate is, and it's called a parametric because t is called the parameter. In this case, our domain for t is -2 to 3. Now we're trying to sketch this thing, so I'm going to cheat here a little bit and show you I've got a table here. We're going to build a table of values just like you would if it was any other equation. And let me explain how you would create this table. So if we look at this x component again, if we put -2, and by the way, that's the first value of our domain. If you plug -2 into the t squared, you get 4, and 4 minus 4 is 0. So that's why x is 0. If you plug -2 in for the y component, you're going to get -2 over 2, which is -1. I'm sorry, -2 over 2, which is -1. So that explains where we got those values. And if we use those values in the table to then sketch our curve, and I'm doing this with my finger, guys, so this isn't going to be a great curve. It looks something like this. The first point would be at 0, -1, which would be down here. The next point would be at -3, -0.5, which is approximately right there. And then the next point would be at 0, -4, 0, which is right on the x-axis anyways. So what you do once you sketch your curve, you'll notice this is kind of a parabolic shape, is you add arrows. The direction as t is growing, you add your arrows. And this kind of gives you an idea of the movement that's going on with this particular parametric equation. All right, example 2, I'm going to focus on simply taking this parametric equation, there's the domain, and writing it in rectangular form. So what I'm going to do first is I'm going to start with the x component of the equation, and I'm going to solve it for t. So how would I get rid of the square root on t plus 1? Well, you would square both sides, and you would get x squared equals 1 over t plus 1. Well, at that point, you could then cross multiply, which would give you t plus 1 equals 1 over x squared, and then simply subtract over the 1, and you could say that t is equal to 1 over x squared minus 1. And again, I apologize, my writing's not better here with my finger. Okay, so now that we have what t is, we can take t and we can plug it in for y. So y, which is t over t plus 1, will become y equals, and instead of t, we would write 1 over x squared minus 1. And instead of t plus 1 on the bottom, we would do 1 over x squared minus 1 plus 1. And then I'll let you guys simplify this, but it turns out that the equation will be y equals 1 minus x squared. Now you guys already know what that looks like, so I'm not going to sketch that curve for you, but you would want to sketch the curve and then indicate by showing the arrows the direction. Final question on this one, and I'll ask you guys to figure this one out. What would be the domain on this curve? And I'll give you a hint. It's based on the domain of the parametric equation. Okay, our third example here is we're going to try to find a set of parametric equations for the graph of y equals 1 minus x squared using the following parameters. So for A, we're going to say that t is equal to x. Well, if t is equal to x, well, guess what our parametric equation is going to be for the x part? It's just going to be t. So I'll just use the symmetric property and flip those around. And then to get the y part, well, all you got to do is replace the 1 minus x squared, replace the x with the t, so it's going to be y equals 1 minus t squared. This would be the parametric equation for this particular problem, so you can see that's actually not too difficult. For part B, That's part A up here. For part B, they're asking us to write a parametric equation for the slope, which is defined as the derivative at some point xy. So let's look at and we're using this equation from the previous one. If we look at the rectangular form, or I'm sorry, the y component, we can go ahead and find the derivative, or you can actually go back up here in this case because x is equal to t. So what is y prime? Well, y prime is negative 2x, or you could even say it's negative 2t, however you want to do it. And then what we want to do is we want to solve this for x or for t. I'll just go ahead and do it for x since that's how it's kind of written first. So basically what I need to do here is just say that x is equal to y prime over negative 2. So now I have my x component, and now I got to write my y component. So guess what I'm going to do with my x component? Well, I'm going to plug it right in here for my t component because x and t are equivalent. So this is going to be y equals 1 minus y over negative 2 squared. Oh, I'm sorry, not y. I think that was supposed to be y prime. This is y prime here, guys. I am so sorry. That's y prime. And my finger's kind of big there. So that's y prime. So that's going to give us 1 minus y prime over 4. But in this case, they wanted us to write this in terms of m. So it's going to be 1 minus. And what is m? Well, m is defined as dy over dx, which is equivalent to y prime. So it's just going to be 1 over, oh, and this should be squared, 1 over m squared over 4. Okay, so last example. This is our final answer right here. This is our parametric equation. Here's the x component, and here's the y component for the second one. Last example, I'm actually not going to do this for you. I'm going to ask you to, first of all, I'd like you to look up the definition of what a smooth curve is. And then what I would like you to do is I want you to watch the video that I have on Canvas about using your graphing calculator to graph parametric equations. I will go ahead and kind of sketch this graph for you. And once again, I'm going to kind of cheat here a little bit because I'm doing this with my finger. But basically, if this is the x-axis, and then this is the y-axis, this is the y-axis, the parametric curve will look like this with the arrows going in this direction. Sorry, those are not very good arrows. Now, this whole smooth curve thing comes into play on this particular graph, and I wonder if you can figure out where that is, but you need to watch the video. So we're at 8 minutes, and we need to stop. Hope this lesson made some sense to you guys, and as soon as I figure out how to stop this video, we'll be done. There we go.